for me to join again after a long time with Dr. Musti. You may
Thank you,
not
sir.
be
Thank you.
knowing, we were together in University of West Indies. That's how I got connected with him. And he moved from West Indies to Namibia, and I moved back to our country. That's what he is. So since maybe more than 15 years, he is abroad, but he's
Yes.
very much involved in our day-to-day functioning of our country also, because whatever you learn should be disseminated to your own first and then to others. So that is what concept he is having. So he is always available for us. Not only us, many people are, in fact, in these 2 months, I think 3, 4 places he has spoken in various institutes in our country, only Bhopal, Gwalior, every place. So I know his capability very much. So if I start speaking about him, then it will be a long time. So I just request him to start and place whatever short things he can place here. But certainly these electrical students and faculty members should get connected to him, because he is practically working on simulators for smart grid and other such applications, not only academics like in our country. Other places, engineering is always with applications, and that is what is taught to students. That's why other students are gaining better and better knowledge than our students. Because once our teachers have not gone for that much practical, then how they will decimate to others? Those facilities are not available. I don't blame teachers here, but facilities should be there. Environment should be there. First of all, there should be environment. You must have heard, it's a small, it's not very big country and very big university. It's years and years together backward than other countries, but still they are trying for this academics better than our country. Even if you compare IITs, if though people want foreign faculty to be inducted in their institute, it is very difficult for them also. But in those, you must have heard person from Germany and other France. There, I think, from 4, 5 countries, teachers are teaching in that engineering department. Maybe more countries. So that diversity, if you have in teaching faculty, then something you will also learn, and students automatically will gain more and more. So that is what environment is required, which to which we are lacking. That's why we need to interact more and more with other people, those who are working abroad or other places, so that at least something we can come to know that what is the concept of their teaching and learning. So for that reason, you should be connected to more and more people, to the universities. Don't be subordinate to IITs, because IITs have given nothing to country. Let me very critical in this. Whatever has been given by state universities only they have given. So we are better than them. That has to be in your mind before you enter in any university. You take any mission in our country, whether it's a moon mission, whatever it is, you will find 99% of engineers are from institutes like us. So don't think we are in any way lacking the other so-called national importance institutes. Our students will be serving our country. So that's why we need to give more and more to our students. And IIT's students will be serving other countries. So that is the difference. That's why we need to give more and more to our students, because they are the students or future engineers who will be serving us, not IIT people. So you try to give more and more to these students, and so that we are benefited in our future. Thank you. You may start, sir.
Thank you very much, sir. Sir, now I request Dr. Bijay Pratap Singh, sir, to cite the biography of our today's eminent speaker. Sir, please, Bijay, sir.
Thank you, Dr. Patel, sir. First of all, a very good morning to one and all present here in this webinar. The expert of this webinar is Professor Kameswara Musti, sir, from Namibia University of Science and Technology, Namibia. The Honorable Director of our institute, Professor T.S. Tomar, sir, Dean Admin, Dr. D.K. Tripathi, sir, Dean Academics, Dr. Amod Tiwari, sir, Head of the various departments, faculty members, and dear students. Once again, I welcome you all in this webinar. So, Professor Musti, sir, is presently working as an associate professor in the Department of Electrical Engineering and NUST Nambia. Sir has done his MTech and PhD from NIT Warangal, India in the year 1996 and 2002 respectively. His research area is renewable energy system, industry 4.0, enterprises information system, engineering education. He is the senior member IEEE USA and Institutions of Engineers India. Sir, having the vast years of the teaching experience and worked as a different parts of the globe, presently he is in the associated with the NUST Nambia in Electrical and Computer Engineering Department. In year 2016, he was visiting professor in KL University, Andhra Pradesh, in India, on sabbatical leave. In 2017, he was visiting professor in Sophia University, Tokyo, Japan. And from 2007 to 2016, he was visiting professor in Rouen, France. And he was lecturer in electrical and computer engineering at West Indies from 2004 to 2018.
कौन सा राजेश?
And he has published a number of research papers in the
वो तो
various
30 का 30 में कराएगा पूरा हर बार. ना ना ना
Now I invite
उसका
Professor
तो हरदम
Musti
करेगा, वो तो हरदम रहता है.
to please deliver his talk on the big data applications in smart grid. Sir, please.
Yes. Is it ready? Very good morning. I just need 2 minutes. My server is starting. Our internet connection may be interrupted. I just need 2 minutes, sir.
Okay,
I'm in
sir.
the studio. Yeah, just need 2 minutes.
Okay.
If I disconnect, I can get back. Am I right?
Okay, sir. Okay, sir. No issue.
I can join. Am I right?
Yes, sir. Yes, sir. Sure, sir. Actually, I am removing some of the students because the limit is of 100 participant only. So because sir is going to join, so he needs place in chat room.
I
So
think still it is 95, so he can join.
Yes. But for the safe side, sir, because
No.
student can join it.
If there is problem, he'll call.
Okay, sir. Okay, sir.
Let him try first, because 95, he will be able to join. So in place of students, you remove faculty, those who are not interested, because students should gain more and more. After startup, I will be getting out, so don't remove students.
Okay, sir. Okay, sir.
Now it's 100.
So this is the problem, sir, actually.
So I'm coming out.
Oh, okay.
पटेल सर,
हाँ सर,
लिंक जो है किससे क्रिएट किया था आपने?
गूगल मीट से.
नहीं, कॉलेज वाली आईडी से.
कॉलेज वाली आईडी से.
अच्छा, उसमें भी लिमिटेशन पहले तो 200 से कम कर
हाँ,
दिया है.
घटा दिया हम लोगों ने, घटा दिया है. 1 जून से घटा दिया है.
100 ही रहता है सर उसमें भी।
हाँ, नहीं पहले 250 था सर, बाद में घटा दिया मैंने।
अच्छा पहले 250 था।
हाँ हाँ सर,
जी जी, पहले 250।
अभी कुछ चेंज किया। सर ज्वाइन कर लिए।
Yes, I'm back. Sorry about that. We have had a little hiccup with. So I have to share my screen first. Am I right? Okay. Can I start? Okay. Good morning, everybody. I hope you have seen my screen.
Yes sir, it is visible sir.
Please mute everything, please. Okay. Sorry about that. In the morning, we have to restart our servers due to certain issues. Most of the students are away from the campus, so the servers are reorganized. A very good morning to all, and my apologies for the little mishap here. I hope there will not be any disconnect from here afterwards and all. Today's lecture, I would like to focus on IoT and big data applications, which means basically we deal with data in engineering applications. I don't want to go into the theoretical aspects, kind of complex algorithms. Of course, we cannot do without algorithms and mathematics, but I would like to show you some practical examples that are very much related based on my industrial experience and consultancy activities that I have done in India. And I will demonstrate two examples actually that I have recently developed and published in big data. And that is the lecture is about it and all that. So without really mincing much, big data and data visualization, in this lecture, we focus on electrical power. Though it is electrical power, I wouldn't expect really the listeners to have the electrical background, complete electrical background. If you see basically what I have put on the screen, basic parameters, for example, current, voltage, active power, reactive power, and power factor. Now, I would like to spend a few seconds here, kind of normally what we spend on every slide will be little, but this is the key here. If you understand these five, we can go through the lecture easily. Now, there will be several substations in different parts of any town, any city, and there will be different transformers, different feeders, several customers, and all that. Now, in the modern times, there will be devices called load managers. What is a load manager? Load manager is a measurement device. This is a basic concept. I didn't bring any pictures and all that. What we are interested in, these five variables. Load managers basically measure, they are part of SCADA system, real-time data measurement system. They basically measure current, voltage, active power, reactive power, and power factor. And they keep on transmitting the values of these five variables to the control center. And these load managers are normally located, let us say a town like a city like Sonbhadra will have definitely like a minimum high voltage points about 100. Let us say there are 100 high voltage points about 132 kV. If you go into 66 and 33, I do not know if Sonbhadra has that 66 kV, which is rare, but there are places, Maharashtra, Goa, UP, yeah, UP has 66 kV and all that. So many customers in different geographical locations, normally, typically, these variables are set in such a way, the load managers are set in such a way, every 15 minutes the data will be, actually every 5 minutes in high speed data systems and all that, the data will be collected typically every 5 minutes, but we consider practical purposes, research purposes, some researchers consider 30 minutes, 15 minutes, different things and all that. So even if you consider 15 minutes, just imagine within 1 hour, how many readings will come from 100 locations or 200 locations. 200 locations is very, very, very less number I'm speaking, because how many customers will be there in Sonbhadra? How many industries are there? How many shops will be there? How many substations will be there? Each place you will have at least 4 to 5 load managers and all that. I'm not talking about individual houses. Okay, so this is the backdrop basically. So designated measurement locations, they will be, each location will have an IP, will have a particular ID and all that. So, and why we are considering this, I am trying to propose how the data is generated, though we will see later how we can generate this data in the laboratory also. As Professor Tomar sir mentioned just now, in universities we will not have the facilities to do everything. We need to make out how we can do these things. In this case, how we can generate big data. Okay, so this is the context. We start with this. Now the lecture outline. Now I'm putting the lecture outline here. The data generation through IoT SCADA, which I already explained. 5 variables we can consider and all that, and data transmission, and how the computing, where the computing should be done, on the site of measurement, or in the control center, or in the computation facilities, or a separate contractor who is doing that. And data visualization, this is where I am very hot. Actually, data visualization is very, very important. We have just signed up with Germans on data visualization. When I looked at that and all that, data visualization is required by everybody because of lots of complexities, which we will see. Actually, I start with data visualization and then we go into the details. We will see a case study on power systems. Very simple, straightforward. One doesn't really need to be a power system person to understand. There is an application called TCMS that I developed in Hyderabad and Tamil Nadu. And my experiences, IoT, big data, cloud, and demonstration of big data projects, these things we will do. Okay. And we will also focus on some basics of Industry 4.0. The reason is in a laboratory, if you want to generate big data, you need to actually use Industry 4.0 and all that. Otherwise, it is not really possible to do that. And some research opportunities in these areas, what platforms I need, what are the best and all that. And some of these things, what are the challenges in academic life, that also we will see. A few solutions and my own experiences. You can develop prototypes with MATLAB, MS Excel, MySQL, PHP. We will come to this slide a little later. Now, look at the screen. This is based on one of the consultancy works that I have done in Trinidad, Tobago, that is in West Indies. That is where myself and Professor Tomar sir, we have invited Professor Tomar sir as a visiting professor there, and he really contributed. Actually, he graduated a couple of master students in his little time, and he actually graduated one PhD student also. That's wonderful for us. Now, this is one of the diagrams, visualizations. It is a published paper. You can see on the company website in Trinidad and Tobago. A PDF can be downloaded and all that. Now, what you see is a 3D image. These on this side, you have all substations, like generating stations in Trinidad and Tobago, Scarborough, Crow, then the Point Lisas. These are the generating stations. And on this axis, let us say this is x-axis actually, and this is really the time in 24-hour segment. And the blue color ones are the previous loads, means like 1 hour, 2 hours, 3 hours past. And this orange color line is the real-time load. As it is measured, it will be displayed. And this gray color or brown color is the future loads, which actually what we call based on past results, past measurements, and the present measurement. These are measured values. Okay. We actually forecast and predict these values. So they are looking like that, and based on that, engineers will plan something. But the question here is, the lecture is on big data and visualizations. How do we get this diagram on the computer screen? What computations are required? That is the interest, because this lecture is about big data. And we have already told you, that load managers are used. In this case, these are all real powers in megawatts, because this is in Trinidad. This is a generating data. So these are all, the generator loads. The load on each generator is represented like this and all that. Now, let me put some questions here. Why we have to have this 3D representation? Why it cannot be in numbers? Why it cannot be in XY graphs? That's a question. Now, this is what you see on the screen is not a kind of ordinary 3D display or 3D. This is a composite visual, what we call composite visual. Let us say you click on this and you can see the data of this generator, this load on this generator, more details, at what power factor, at what time the reading is taken, and what percentage loading is there on a lot of information is captured in. So basically each one is a object by itself. Now I will rotate the diagram a little, I don't rotate here. A rotated diagram will be seen in the next slide. Now look at this. This is the same diagram. This and this are same, just that you see differently. So a little more details will be here and all that in real time. These details you will not be able to appreciate because you will not be able to understand. The reason is you are not connected to the problem, technical problem, or the realities or the data information. Now I bring the context of data. If you are not related to, if a person is not related to the data, they will not have any interest, and thus the kind of what we say, the challenge in learning and assimilation, the person will not be able to assimilate with the data. So we don't really go into the details. We actually stick to the displays more, and data acquisition, data transmission, and data display, data visualization, what we call. You look at the heading. We actually used our own custom user interface and all that. This is not a cloud application and all that. Now, this is the graphical editor, and because since we have taken a kind of example, power system example and all that, let me explain how the data, where the data comes from. This is a substation basically, and this is the small triangles are basically the distribution transformers. They are not power transformers. The power transformers will be located here and all that. Ideally, we need to get data from all these distribution transformers also, assuming that this is a 11 kV distribution system. Okay, please understand, we will not be able to collect, though it is theoretically possible, we will not be able to collect at 400 volts or 230 volts and all that. Forget about it, because there will be millions and millions of points, and it is not practically possible to collect the data. Even if the data is collected, there is no mechanism to store. Even if it is stored, there is no way we can actually compute it. So basically the data is at the best, actually right now, from the power transformer only the data is connected, means one substation, one load manager. That is what the context is and all that. Now this is another work in Bhutan, the same thing, but it is in real time. This is used in right now. Bhutan uses AutoCAD only. They don't have, because it is very expensive proposition. Somebody like you, means the graduates of modern graduates actually do these works and all that. The idea of putting this visual here is, this is published actually, you can see on energy audit, domestic energy audit in Bhutan, Phunchilong town. The idea is the students must be able to do the projects like these. How do you take the map of Sonbhadra and do something like this? We will see those things a little later and all that. Okay. So this is again a huge data. You would capture the road information, you would capture the transformers, feeders, pillars, mini feeder pillars. So many things will go into that. At the end, you get a diagram like this. Well, you collect the data, in what form the data is there, and how do you represent this, and how the users, stakeholders can see what software they have to use, and how do you provide, what are the computations you provide on that. These are the things that we need to really consider on this and all that. Okay, these diagrams look very nice and all that. I told you repeatedly, once as long as you are not connected to the problem, you will not be able to appreciate. So we start with a simple kind of example here, what we call TCMS, trouble call management. These are some of my recent publications. Quantification of demand response in smart grids actually is one of the big data applications and all that. JS model also, smart city. This I have done with Kuntal Ghosh. He is in IISc Bangalore, postdoc student. These are all related with big data only. Okay, now we go on to trouble call management system. In this, what we use is that because we need to get familiarized with the data, how the data is generated, and how engineering problem is defined, and how the data is generated, how it is processed, and most importantly, why we need big data. First of all, remember there is an area called service computing in IEEE. Service computing, at the end of getting the data and all that computing, we need to be able to serve the people. In my opinion, electrical engineering, power engineering provides, probably that is the only area. I have been seeing different areas. I have worked in even medical sciences. I don't see any better example than power engineering. Probably the reason is I understand power engineering more. So this system I will present to you. It is a very simple system. And software applications and big data applications, everything we will see, and how the customers can be benefited, which means data to service, whole WIPZR we can see and all that. This was first designed and implemented in Hyderabad from me, but there are many people who have done trouble call management system, many engineers in India in different boards. To my knowledge, somebody told me in Punjab it was done for the first time. And but they have used Lotus 123, which is a spreadsheet like MS Excel today. So it can be done in different ways and all that. Actually, it is very nice thing. But we have done in a corporate style in Hyderabad. These are the papers, actually, integrated outage management system, or trouble call management system, if you want to understand this more and more. And it says effective solution for power utilities to address customer grievances. Okay. So let us understand basics, and then we see how we can really, okay. What happens when a power in a home goes off? What should the consumer do? Basically, customers in Hyderabad, there are different phone numbers across the country. In Hyderabad, even today, it is the same number. You dial 1912, and normally you explain the operator what has happened and all that. Usually faults in the homes can be a fire accident, a short circuit, a fuse blown off, MCB tripped, so many things that can actually, there are more than 70 reasons why customers call a call center. Now here the number, 70 reasons. That's a big number. When you talk on the phone to an operator, the operator expects you to tell one of the 70 reasons. Even if you tell something, the operator really has to select that on the system, to put that on the system and all that. And faults outside the home, typically a tree falling, which may take 4 to 6 hours to restore. Again, numbers, look at that. Major fire, 3 to 6 hours to put off, usually, because fire tenders have to come and fight and all that. Vehicular accident, sometimes involving poles and transformers, because we are interested in electrical assets and all that, 1 to 6 hours. Why we need this information? How I am telling you in the lecture that 4 to 6 hours. This is the beauty of big data. Over the years, whatever state it is in India, the engineers are working with trouble call management systems and all that. Over the years, they actually go through the statistics. Now, how the statistics are collected, the big data. Each call, whatever it comes, they record, and they actually record the time of restoration from the complaint to the switching on the power, returning the power back to the customer. That is what we call fault restoration time, like restoring the system restoring the time and all that, or power restoration. So usually tree falling is cleared in cities in about 4 to 6 hours time. That is the max. It won't take that much time really, but generally, to safe side, when the customer calls, the operator should be able, let us say you call the system, the operator will tell you immediately, madam, don't worry, there is a tree fall on so and so street, we have switched off the power, and it takes 4 hours or 6 hours, something he will tell. To tell that, to be able to tell as a kind of a standard practice, we must have a lot of data. So that is what the system we are looking at. And first of all, what type of problems customer experiences? I have already explained. How do we know the exact reason of power failure in a home from the call? You won't believe the software. I don't want to go into the details. It is well published area. The moment customer calls, the operator will punch in the customer details, like 1 or 2 details. They don't ask much details in any state of India normally, and they will be able to tell the customer immediately actual reason, because the software will analyze the big data and will give them the fader is stripped, substation, there is a power, there is a fire, or there is a maintenance going on in that street, something they will tell and all that. And how to know where the customer is located or where the home is located, all these are automated. In a small town, there will be different substations, feeders, and transformers. There's a bird next to me, it's disturbing. Okay. In the case of fire or substation transformer or a tree fall, we can expect many calls, what we call power, everybody says power failure. And systems will automatically pick up from the SCADA. When you get the 0 readings and all that, you can say that there is a major power failure and all that. Okay, the algorithms will be there, which we don't. I told you we don't go into the algorithms and all that. So we develop. Let us consider that a trouble call management. This is the system itself is called trouble call management system. Is a huge system. It is also there in Delhi, but Delhi software is currently under revision, a major revision and all that. Very large data sets, both static and dynamic. These softwares basically operate. There are lots of databases that pump a lot of data into the system, and the software must be capable of dealing with the data. So at this point, in this part of the lecture, we don't really care how the data is collected and all that. Customer data, where it comes from. The revenue data, billing. Sometimes customers do not pay the bills and we disconnect. And one of the inmates of the house may not know why the power is gone. Immediately they call and we will be able to tell everything is all right, but you did not pay the bills. That is why the power is cut. So you pay the bills online or something and your power will be restored automatically. So to tell that, you need to have an integrated software. Okay. We need GPS, JS, data visualizations, everything. So if you see by now, you can understand this is the single most example. Even actually, a big data specialist from IBM has considered the same example that I'm actually telling, and it is very interesting. Okay. Now, this explains, this is actually from ABB. ABB is the first one to provide a corporate level solution in Tamil Nadu first. And then I worked with them in Andhra Pradesh and all that. At the time, it was Andhra Pradesh, yeah. First, customer calls. There will be customer compliance and recovery information. There will be a service, customer service. And first, it will be checked with sales, then accounts and asset management. A lot of routing will be there for every call. And at the end, we actually, if there is something that needs to be done on the ground, We send it to repair and maintenance, engineering works, and finally it will come to the control center, and it will be dealt with the substation for switching off the feeder, and then it will be restored, and then it will be coming back to the customer service and all that. It is calls closed. And if the customer is a VIP customer, who are VIP customers? It is very interesting. A hospital, a big hospital is a VIP. Airport is a VIP customer. Assembly or a parliament, these are VIP customers. It is not really the individual who is called VIP. Then high value customers. High value customers is an industry. Again, a big industry is there. Let us steel factory or somebody who is paying big bills and all that. We normally call them back, and we say the call is closed and all that. For normal customers and all that, we don't really call back because the numbers are huge. Remember, we are dealing with big data. Okay, so this is the ABB approach, and this is my approach and all that. More or less the same thing. A customer, when the customers call, during my time, we actually modified the process. People actually do an SMS. They can do lots of things to lodge the complaint and all that. So trouble call center will have 24 hours hunting telephone systems. In Hyderabad, there are about 40 operators work in 3 different shifts. So in a day, there will be 120 operators and all that, and it works 24/7. Call registration, call priority, type of calls, case creation. So basically, what happens is as the calls come, earlier case, I have told you the voltage, 5 parameters: voltage, current, power factor, real power, active power, and all that, active power and reactive power. They are generated by the system. In this case, humans generate the data. That is the difference. You get calls from interactive voice response systems, telephone calls, web calls. You have so much of, you have the crew, and you have the feed from the data, location. This is how different nature of data of different natures, actually they get into the system and all that. Now you see the databases. Now these engineers and students can understand this very much. We have the load shedding data, fault section estimation, supply restoration, customer information system, work management systems where crew will be there, work management systems, and GIS, where the crew is there, where the customer is located, where the substation is there. All these things, all these databases. Why you need, for example, a supply restoration module. Supply restoration module is very interesting. Let us say there is a tree that is fallen. Immediately big data will be analyzed. How many feeders are serving that area and all that. Some feeders will be snapped and the power will be rerouted, and that part is computed with supply restoration type and all that. Okay. So this what we call a data mart. I don't know how many of you still referring as a data mart. This is a kind of a word field level terminology that we use. The data is actually put in 3 segments: historical data, transactional data, and the master data and all that. Okay. And this is the software. It's just this is how it works and all that. I have written in 2003. I can do still do a demo and all that, not a problem, but that is not relevant here and all that. Now this is one of the visualizations. This is in Hyderabad, TCM deployment Hyderabad. This is the famous Hussain Sagar Lake where the statue of Buddha is standing and all that. Remember all this. This is a composite visual. In this case, this is also a composite visual. The colors will change. The green one means there is power. The red one means there is no power. And one needs to have a lot of computational abilities to display a graph like this and all that. This is the ABB screen, and I will show my screen and all that. And this is Begumpet, where the old airport was there. Well, it is now used. It was the original airport of Hyderabad. It is now used by Air Force and all that. So this is Erragadda. This is where the control center is there and all that. These are all Erragadda. This is called line diagram. And if you see here, local, remote, local. One guy is in remote. So this, sorry, one guy is here, 24.4. This guy is in local mode, means this guy will not be able to supply the data because he is operating in local mode. Those who are in remote modes, they will be able to supply the data into the system and all that. These are all very interesting. So real-time aspect is also there and all that. This is my software when the local utility actually shifted from ABB to our software. Our software is much more friendly and much more powerful than them. So, and this is a vector diagram, what we call vector diagram. This is how we mimicked the ABB system, but this is how it is displayed and all that. Okay. I'm not going into the details and all that. I'm skipping these things. And this is the SCADA center. That this is me. The second position is me at the time. The whole screen, actually, the whole wall is a screen, as you see and all that. So some computers are still with the old ones, and some computers are with my software and at the time and all that. So basically, this is how the big data will come. And don't think that one or two normal computers can do the job and all that. No, it is not possible and all that. These are the requirements. We don't go into the because it's all full of data, but I have given you the kind of background about this and all that. The activities and the algorithms, network switching, reconfiguration, this happens on a continuous basis in any city. You won't believe it happens on a continuous basis, because they have to do some work or somewhere on a continuous basis. They have to fix and they have to reconfigure the system so that there is no power disruption for long times and all that. And when they do, when they disconnect the networks and all that, the disconnection time should be shorter, basically shorter and all that. And it is for that we will, how do you minimize the restoration time? We employ economic dispatch problem and all that. Then we have the voltage control, trouble call management, and load flow. Lots of studies, they go into the data. All studies require data. Okay. Now, obviously, the focus of interaction is on databases. There are lots of graphics. We have seen databases, graphics, JS, GPS. We have seen the maps and all that. And cloud computing, we looked at something. Because this is a lecture, it will not be possible. And this all actually gets into the big data and all that. Okay. Now, there are lots of R&D development opportunities in this. That on the databases side, we have graphics, JS, GPS. This is ever evolving. Right now, we have a new software that has come up, open source software. Google is no longer supporting the development. That means you cannot use Google on the computer for real applications and all that. But don't worry, we have new open source softwares in that actually allows you to use databases, graphics, and JS, GPS, and all that. High power service cloud computing, that is something like trouble call management system and all that. And in the laboratories or even in SCADA, applying IoT is a must, and it is the way to go, because the data is generated, computed. Earlier, we used to call high power computation, high performance computation. But now, with the advent of IIoT, a lot of edge computing and fog computing and cloud computing has come in 3 different stages. And it is slowly, there is a transition from high performance computing to IIoT and all that. So we have done lots of things and all that. What you see is a desktop application of mine, and this is actually a cloud application and all that. How do we do that? And in service computing, a large display environment is also there. In this also, you have a lot of research and opportunities. For example, what you see here, why I put this diagram here, you have actually 4 TVs here. If you observe, the whole display is actually kind of, there are 4 parts. Basically, there are 4 TVs, large LED displays are there. So if you have 4 or 8 or 16, how do you program them so that you see one image on a big screen. This is the research problem right now we are dealing with. This is a good one, and this is from load dispatch with multiple display environment. That is called multiple display environment and all that. We have not really solved it, but this is a problem that is open. If some of you can take up, it will be very interesting and all that. Now, first cloud example we will see, taking desktop to cloud, and what are the implications in data we will see. This is we have seen this already, and we are looking at, this is a composite image I told you. This is how the visualization will come, and actually visualizations will be in different layers. Look at that. On this case, these are let us say this is actually data of poles, and these are contours, roads and all that, and these are the poles on the roads, and these are some of the kind of water resources and all that, and these are the temperature measurements, and different layers you can put and add them together. And we have actually worked with Trinidad and Tobago Electricity Office in a kind of small student project. Actually, we have done the work, and it is published actually. Distributed cloud computing based JS solution for electrical power utility asset management. This is the how the layers look on the screens. This is how, if you see, this is the map of Trinidad. This is what the student has developed in Trinidad and Tobago. And on the first layer on the top, basically what you see is the poles. Look at that, only data is there. And the second one, you have the map of the Trinidad and Tobago. And the third one, what you see, the line map of Trinidad and Tobago is superimposed with the data collected from the first layer. So the final layer looks like this. This is what is geo syncing or geo map syncing and all that. These are the projects that. Now let me propose a small work to Sonbhadra. Okay, you take your college campus, a small example. Can you get the map? Yes, you can get from Google of your own campus and all that. Let us say you don't even have the map of it. Okay, just send a drone on top, or you go onto a building and take a picture with your cell phone. You will get this picture. Then you collect the data of the buildings, you collect the data of the electrical wiring or electrical poles, transmission lines and all that, and you must be able to get. That is an excellent student project once properly done and all that. So these are the things. In this case, it will not be big data really, it is the data visualizations, but this is what can be done in a kind of university environment and all that. So, and now, what you can do, how do you provide service out of that? Basically, let us say you have the map and you are showing the buildings and lines and all that, and you can show the departments, buildings and all that. In this case, what you are seeing is Trinidad and Tobago electricity departments and all that. So users will have the map as visualization. They will have the buildings. When they right click, left click, they will get the information. A lot of information will be there and all that. Okay, we will see actually an example with the data and all that. I will demonstrate but not this one, because we need to have a complete internet connection for that and all that. So this is the service. The same thing you can provide. Let us say you have electrical department or a computer department in your engineering college on a map and all that. You can actually develop a database like that, and every student, every user must be able to see the same thing and all that. But that requires a lot of data behind. And what you see here in Trinidad and Tobago, the roads and the poles and the lines, electric lines and all that. If you see the representation, this on the screen, it looks very nice, very, very nice, but somebody has to go. The student actually has traveled on a small bike and he has taken all the readings like this. This one, if somebody can do for a locality, this is the data collected and the programming is done on top of this. And this is a practical example that can be done by a student project. A finally student project can be done with this, within that. And I wish I can come to India again once the COVID is gone, and we will see how such projects can be done. I will be there to assist and supervise and all that. Well, these are some of the things. Because I am discussing, I put the same project, like, and now on Google Maps, this is done for KL University actually in Andhra Pradesh. That's a private university, one of the large universities in South India, and we have done on Google Maps and all that. The same. This is in Trinidad. This is all in Trinidad, and this is in KL University. Once you have this map, you can actually put the SCADA information, electrical systems and data and all that. So what is the point in showing these works and all that? The GIS and GPS layers we are covering right now. There are many layers in TCMS. So we have to cover one layer after one layer. You have to create the databases. And then on top of that, you will be able to develop a system so that you can serve your customers or stakeholders and all that. That is the point here. Okay. So it is a lot of data, and this is all done in KL University. In 3 months, I have done this actual buildings in 3D. We have taken from Google Earth the pictures and all that, and the same information basically. And these are different visualizations. You can see the main gate, bank and ATM here, a transformer and all that. This is in KL University. If you see, this is the Google Earth map and all that. And the projects, how it look, if you really want to do a big data project and all that, and one class, they have to have about 8 to 10 projects in a go, and then different layers can be done, and a lot of data can be collected. You need to have at least 4 or 5 computers, normal lab computers, to do a kind of barely working big data project and all that. So the projects, how they look like on the screen is this. We are still dealing with the JS and all that. Now, data computation and visualization. How do we? So far, we have seen kind of data representation. The GIS and GPS layers, basically, they look like this. The computation on this layer will be very little, because we don't compute distances and all that much unless it is required and all that. But computation and visualization, we will see and all that. Do we have a simple problem so that I can learn what platforms we need, what are the best? In this case, what we do is that I will take what is called a demand side management, small data, not to bore you with big data and talk like this, and then show a visualization and a computation and all that. Okay. This one, we start with a simple setup in a laboratory, what we have done in KLU. So just how this can be done. In many teachers ask how we can do in laboratories, what we can do. You need to use Industry 4.0 setup. I have developed in GIS and GPS in laboratory itself. We don't have to really have big systems. They will be functional prototypes. They need not be proprietary systems that can be commercially used and all that. But now in the KLU in Vijayawada, what I have done is that I have taken a simple, what you see on the screen is Arduino, and a relay and a Wi-Fi module we have taken, and there is a load we have taken, and we have used actually a kind of switch, a normal modem as a web server, and a gateway also, and one computer and all that to establish complete SCADA system and all that. This is what can be done in the laboratory without any hesitation. You can develop everything, and this doesn't cost at all, kind of up to 5,000, 6,000. If you have 2 students, they can do by themselves and all that. What you see is Node MCU basically we have used, and this is the modem that you can see and all that. And the setup, this is another picture basically here, Arduino, and we have kept kind of luxurious setup, one Arduino for one node we have kept, and we established a private Wi-Fi network. We did not use, once you have the modem, you can have your own private network. It will not be super fast, but it will do the trick. Okay. And now this is a low-cost GUI that can be developed in laboratories. What you see is a boys' hostel, staff apartments, ladies' hostel. What we did is that we kept one Arduino at each place. and we get the CB status and current. In this case, what happens is the IoT equipment, they will get the current, voltage, active power, reactive power, and all that. Within no time, you get this computer loaded with a lot of information. Even with, we have kept 5 nodes, and by evening we get a lot of data and all that. So basically, you are generating the data within your system and all that. So this is the basics. I don't want to go into the kind of data and all that big data. That comes at a kind of different level. Computer science people may not be interested in this. They start when the data is already there and all that. But in reality, we need to be able to generate our own data so that we can actually speak about it and all that. And this we have demonstrated in 2015 in a conference to the participants of the conference. And you can see some participants actually using. Yeah, we actually developed an app also where stakeholders or students or whatever, they can actually use their cell phones to get the information, and it's not just the computer and all that. Okay, and well, these are some photos from the conference at the end and all that. In Namibia also, we have done the same thing. We collected the data from 2 areas, Area 1 and Area 2. And actually, this project is now funded by Africa Development Bank and all that. And this is the guy, Jaleel. This is an Austrian bank executive. He is the funder, and we got funding to do a kind of big data project for demand side management and all that. It went very well. We have done in 2019, and last year November the project was sanctioned, but I am not able to do anything much because of the COVID. We are not able to do much and all that. You see the student, actually this is the student who developed. Why I am telling all these things is that it is possible to develop these things even, see, in India you can do all these things just like that. Because once you are in India, probably you're on top of the world. For me, that is how I look at it. What you need is the problem. Problem means engineering problem, and know-how, a teacher probably who has the ability to go along and all that. And that is about it. Most of the softwares are open source softwares. That is the advantage of IoT. And we can do wonders and all that. That is my intention, not to boast about what I have done and all that. Actually, to ask me and all that, I may not be able to explain in detail what I have done, because the time is one thing. Second thing is that I am not a person who really kind of goes and explains about what I have done. My intention here is to, even if 2 projects that come in REC Sonbhadra, that would be a great advantage and all that. It can actually create a small vibe in IoT and big data. We have done, as you see here, current sensors are used and all that, well tested, calibrated, loads can be remotely controlled, readings can be obtained and remote. If you can establish this, you will be, those who are from IIT Kanpur, actually electrical engineering, they have this kind of last 30 years, they have this system. They used electronic equipment in those days, cheap electronic equipment. Actually, they control all the staff quarters from the electrical engineering laboratory and all that. Those who are actually from IIT Kanpur in REC Sonbhadra, they may know what I'm speaking and all that. So it is possible right now to do these things and all that. Okay. Now let us go into data visualization and computation. Consider I have done this for WIT Dehradun, as Professor Tomar mentioned and all that. February 9th, I have lectured, and I'm using the same example here. Let us say, I told you data is collected every 15 minutes or half an hour. In this case, I have considered, to simplify the proceedings, I have considered half an hour interval. Now, please observe, there are 3 different categories are there. Domestic is there, commercial is there, industrial is there. Okay. Now, time of the day is given here. Time of the day is given here. Time of the day is given here. And this customer at 00 midnight, this is the average kilowatts. At half an hour later, slowly the readings are going up, because as the day progresses, this is the reading and all that. This is not for a house. This is for a feeder please understand, we don't really deal with one customer because will be huge, too huge. 73 kilowatts means normally a house in a domestic house is kind of around 2.5 kilowatts, not more than that. And the readings at 2.5 kilowatts at one time can be high reading, actually, very high reading. So we are talking of 73 kilowatts means it is a feeder that is going to typically kind of a complex, apartment complex of about 100 apartments or 50 apartments. Let us say 50 apartments and all that. That's a fair number here. 50 apartments, 60 apartments or something. Now this is a commercial, means a shop, basically shop. And then this is industrial data. Why we have to have three categories here is the billing is different. Now I am telling the data, computation and everything. Now domestic customers will have a different billing costs, kind of tariff system. Commercial people will have different costs. They may have their own solar systems also, and they pay the difference. Okay, and industrial customers also have different rates. They may have solar PV. They may have different systems also, like solar water heaters and all that, and they will have different systems in their place, and they pay the difference and all that. Now let me explain. Domestic people will have different billing systems. Importantly, in India at least, they do not pay by the time. Whatever they pay, they just pay. But in India, they what is called a telescopic system will be there. First 500 units, this much cost. First 200 units, this much cost, and next 500, so and so will be there. A commercial and industrial, this is where the trick is. The TOU, time of, you need to bill them according to the time. For example, from 9 to 12, 9 to 2, the what is called peak tariff will be applied. So it is not just the data and billing and all that. Based on different parts of the day, the billing is done differently at different costs. So that is where things get complicated. So this is the data, and whatever I told and all that, I actually have shown some calculations here in Namibian dollars or something and all that. And the calculations and all that we will take easy now. We don't really apply much here, but let me show a kind of a quick demonstration here. I hope you're all seeing. I will show a demo of this directly. Okay. Okay. So I hope it will be visible to everybody. Now what you see, let me actually zoom up a bit to explain. I have taken one case here. This is the time and this is the load. Same 73.5, 74.4, same thing I have taken. I hope it is the same thing. Yeah, more because these data points vary significantly. So these are the data readings here, and they go up to 23.5 here, means you can see 23.5 means midnight, 23.5 hours and all that. Okay, and this is what the load, because the load is increasing and then decreasing as the day goes. This is the visual. This is done on MS Excel. You can do lots of things. I don't want to go into the details of the platforms and all that. We have done on databases, we have done on Java, we have done on Python, we have done in R, we have done a lot of this is the one that we can explain in lectures like this. That is the reason I'm using MS Excel here. Let me delete, and if you plot the plot, this is how it works. Okay, so basically it is nothing but a simple plot, and this is understandable for anybody. As the day progresses, on the x-axis you have up to 24 hours, and this is in kilowatts. That is fine, but engineers do not want this. Look at this same data, they want in a different way. Please understand this point. This point is very important, because earlier also I told you the data may look like a graph, but engineers may want differently. Normally a customer is fine let us say this is a commercial customer. Commercial customer is okay with this graph. On that day, on that particular day, the load was varying like this, and billing can be calculated on a different, that's a separate story. Now, the same data, how the utility wants. Now, when I click this, they want, utility engineers want the same data in a different way, what is called load duration plot. And how do we do that? Now let me click. When I click that, this guy will disappear. Look at this. The same information, and this is, and x-axis is same. This is very interesting. It is called load duration plot. Those who are in electrical engineering, they know it very well. Others just how do we do it? Now, what is the difference between this and this? The difference is, in this case, load duration, it is for planning purpose. There are 1, 2, 3, 4, 5, 6 levels of and data. This is, let us say, what is the base case? What is the minimum load and how long it existed? The minimum load is about some 60 or something. It existed for all 24 hours. So this is called base load. We call it as base load, which means the engineers must be able to pump, generate, and supply this much of energy continuously throughout. So same data you have. So we write a small algorithm here. That is the computation process here. In this case, it is simple. I don't want to bring a complex example, though we have a demonstration of a complex system. And then at this level, it exists for about 9.5 hours. And at about 175, it exists for 5 hours. And about, this is 240 kilowatts. That means 240 for 5 hours, the engineers must be able to supply 240 kilowatts of energy. At what time, that's a different story, but they need to have the resources for that. For example, 300 kilowatts for about 4 hours they have to supply, and 350 kilowatts for 2.5 hours they supply. Now look at this, the beauty of it. At peak 300 kilowatts for 2.5 hours. Kilowatts multiplied by hours, these are units. You can directly understand the bill. At this stage, if you bill high, because this is very peak load, the systems will be stressed. And if you apply a different tariff, engineers will be able to understand how much revenue they get and how much cost it will actually occur for them to produce and all that. So there are certain things that we basically interested in: minimum load, maximum load, how many steps and all that. That is for internal calculation and all that. So this is the first stage of, then what is called peak shaving. This is interesting, very, very interesting. Those who are into data, they will know what it is. Okay, we delete the plot. The same data, I did not change any data here. And it is too much. Okay, let me put it. And now let me delete it first. We start with base plot, and this is the base plot we have already seen. Now peak shaving. One of the problems with power engineering or the power transmission is, what happens is that during this time, the midday, this is the problem. This is the big data problem actually, 9 to 14 or 9 to 15. The power will be peaking up. In this case, it is 350 kilowatts. It is only for demonstration purpose. In normal things and all that, it will be normal situations. It will be megawatts and megawatts. This region, the high power, will be actually detrimental. It will induce a lot of thermal stress and electrical stress, heat stress on the transmission structures, and all devices will be subjected. So what is called a peak shaving? Normally, they would like to shave off this peak and all that. How they do that? There are different techniques and all that. You can actually put the variables here. If I click this, it will go. Which means in this case, we actually subtracted 100 from each reading. So if you subtract from here, let us say 100 from each reading, the graph will be like this. For example, if you subtract 100 here, it will go down like this. And if you subtract 100 from this, it will not go this much down, like this. So the new graph will be like this. But in the textbooks, they show a nice kind of straight line and all that, which never happens because the loads are varying. What we call capped peak plot. It will be like this. But this is only for textbooks, those who do not understand the field reality. The reality is, if you shut off 100 kilowatts, it will look like this. Okay, you can actually change this. Let us change it to 200 and see what happens. It will go further down because I change it to 200. Let us say we say only 50. It will go up and all that. So this is one of the peak shaving. This is a very standard technique. Peak shaving is one of the well-researched topic, how it is done and all that. And we can actually get a lot of things done here. If you put 300 and do a capped peak, it will be appearing like this, because it is, this is what actually, this graph actually looks kind of odd, because it is capping at this level and all that. So you have to, one has to be very careful with the data also. And now we go into solar PV, same data. Now what you see is a composite, same data. Okay, delete the plot and base plot. On this, let us say if a customer is adding solar PV and then adding solar thermal, and some customers are adding both, what happens is that the revenue to the board will reduce because the customer is generating their own energy. How much you lose, how much utility loses, how much the customer benefits, these are very important. These are not very well researched yet in big data, though there are techniques and programs and all that. So for example, if I add solar, some solar, which you can actually look at that solar. Interestingly, solar PV also should have IoT. This is the problem. Most kind of people, they don't understand how the data is generated. That is the reason I took pains to explain the earlier times. So a solar system also should have an IoT system where it will pump some information to you and all that. A solar system typically will not produce anything up to certain part of the day, and then it will start producing. So basically what you see, the solar is kicking off from 7 o'clock and kind of tapping at 6 o'clock in the evening and all that. It won't be that long, but it will be something like that, only for simulation purpose. And if you add solar thermal, like water heater and all that, water heaters will be used, they will produce hot water, so people don't consume electricity at the time and all that. This data is, if you want to superimpose both of them, you have solar thermal and you have the solar also, and this is the reduction, and computations go on and all that. The computations are typically like this. Sorry about that. So base energy is this. These are energies, so that one can be one will be able to do the billing and all that. Okay. So a capacity factor. This is what most important thing. I don't want to go into the details, but these are the data and computations and all that. Valley filling, you can do lots of calculations. Load growth, energy mix is one of the big area. This is where big data applications are not yet done, and we have a small application here. What you see on this is that this is the coal generation. I will explain quickly because I know it is almost 1 hour 45 minutes. This is solar power, solar PV plant, because it occurs only during the time and all that, and this is how it will be. When you superimpose, when you add coal and solar, this is how the total looks like and all that. Okay, please understand, this is at 350 peak, and this is at 60 watts, and this graph is drawn at 390. Those just pay attention and all that. I would like to show one big data application quickly, so that this is what is called load research. This is truly big data of Namibian data, what we have done. Okay, this is the last demonstration that I have. This is real big. This is a huge data from 2015 to 2020. I have got done with a student. Actually, one student has done, a final year engineering electrical student has done this again on MS Excel, and now we are doing on a database. And why we do like that is that, remember, the students have their own limitations. They will not be able to do everything in the world, and whatever they do at the best work at the time, and it may not work even after that and all that, but that is fine for a student and all that. The teacher will take the project up with the next student to actually develop a semi-industry ready project and all that. So this student has developed in MS Excel. Now we have at least something to talk and to display, to explain to the next student and all that. So we have the data from 2015 to 2020, and commercial, we have the commercial loads, domestic loads, industrial loads, municipal loads and all that. These are different visuals. This is the monthly load trend and all that. You can see that. And how much wind is generated. We have the generation data also. You have monthly wise distribution. Let me click on May month. It will change like that. And you get the data in different, January month. And this is the commercial loading. If you see the loading and all that, the commercial loadings, industrial loadings, municipal loadings, and weekday, if you want, the readings will be there. And region wise also we do. Region wise, Comas region, and let's say you want to do in 2018, this is the kind of, and if you take up the filter, the graphs will come back and all that. You can do a lot of filtering, lot of slicing and all that. That is big data basically. What I have done is just one filtered and slicing and all that. These are the data that we have collected and all that. This energy dashboard is a very important field activity and research area. So what I have shown is a big data based dashboard. It is not possible in this lecture to go into the details unless one is interested in all that. So with this, I actually stop the lecture, the data generation to big data applications and all that. Sorry about the delay again. And with this, actually, I stop and actually get back to you and all that. Thank you very much.
Thank you, sir. Thank you, sir. Any queries from participant side?
Thank you, sir.
Any questions?
Good morning, sir.
Good morning, Vijayji.
Sir, actually, I want to know that whatever the data you have used, these are the real-time data?
Yes, it is the, see, real-time data means it is collected and then used. But you need to be careful. When it was collected, when it is just taken, it is real-time data. But the processing is not done in real-time data. It is static data from the past to now. It is not a real-time data because we are not processing in real time. Okay, you need to be careful. Yeah, context is very,
Okay, sir.
Yeah, good question.
Any other queries?
Sir, can we get future collaboration in the research or other activities?
Of course, yes. If I'm there, yeah, I would be grateful if, I know Professor Tomar sir is there. He is a very active lecturer. He is very active researcher. He is my mentor actually. And the kind of pace that Professor Tomar sets can be very intense, I would like to say. I will be grateful to come to Sonbhadra and work with you, a couple of projects and all that, initiate and all that, even to stay there and all that. Yes, we can do, even now we can do. I have the data, we can collaborate and all that.
Okay. Thank you so much, sir. Thank you.
Yes.
Any other queries from student side?
Any questions, please ask, because we have lots of projects, but this COVID time we got a bit slowed down actually. Otherwise, morning to evening, now we are very hot in South Africa and Germany, Frankfurt. We are doing different projects on big data and all that. The problem is people talk about data, and I would suggest students, there is no shame if you work on MS Excel or the best. Let us say if you are really feeling shameful to work on MS Excel, fine, don't work on. Use R to develop dashboards, and I will provide the data. That is not a problem. And you don't have to depend on somebody. Go to Elsevier. There are data sets are there. Just use R programming and make it a kind of, and Python is there. There are lots of platforms are there. MATLAB also you can use and all that. That type of work at undergraduate level is quite adequate actually. Learning R will take about, trust me, learning R, I have learned in one day. If you have YouTube videos, you can do it in 2 days, 3 days. That is about it. Basic plotting and all that. But one thing, by then the student would be knowing C++ at least. I think C++ students learn in first year itself and all that. There is no issue and all that. If you do not know anything, it will take long time. The problem is if you have the data, where you keep the data. MS Excel is a database. Then if you go into MySQL, getting the data out of MySQL is a problem. R with MS SQL is a kind of issue and all that. Okay. Any questions from the student side?
Sir, can we place this? Can we place this recorded video on our YouTube channel, sir? College YouTube channel.
Oh yeah, no problem, sir.
Okay. Okay, sir. Sir, feedback. I request to participants. The feedback link is available in the chat box. Please fill those feedback form. Chiranjeev sir, please continue.
Yes, sir. Vote of thanks. So, respected and our most distinguished eminent speaker of the day, Professor Kameswara Musti, Electrical Power Engineering, Electrical and Computer Engineering, Nambia University of Science and Technology. Our respected Director, Professor G.S. Tomar, sir, respected Deans, all HODs and faculty members. So it is a great honor and a privilege for me to propose vote of thanks for this webinar, Big Data Applications in Smart Grid. First of all, I would like to give my hearty vote of thanks to our eminent speaker, Professor Kameswara Musti, for his thought-provoking and interesting address. Thank you very much, sir, for sparing your valuable time for us. I would like to express profound gratitude to our director, Professor G.S. Tomar, sir, for all the motivation and support to organize this webinar. We are grateful for your invaluable guidance and support all through. Last but not the least, I am extremely delighted to express my sincere vote of thanks to all the participants for your cordial cooperation. So the link of this webinar is available in YouTube for your future purpose. Thank you all.
Tomar sir.
Okay, thank you, sir.
Thank you, sir. Thank you very much.
Thank you.
Thank you, sir.
Thank
It's
you.
the right time I
Thank
joined
you.
Director
back.
sir is here.
Yes, sir.
So,
How is
you are
life, sir?
working from institute only as of now?
Yeah, because at home, what happened is that the whole country, the fiber optic networks are reorganized to cater to the educational institutes mainly. So
Okay.
the regular mobile data from home is not, but here I have the studio and
Okay,
I am in the studio and I am doing the things and all that.
Okay, thank you, sir. See you soon physically.
Sure, sir, sure. I'll be very glad to come, sir.
Okay.
Yes, sir. Thank you, sir. Thank you. Bye.
Okay, it is requested to participant. Please fill the feedback form as soon as possible. The feedback form is available in the chat box. Okay, so here I am going to end this. Thank you, sir. Thank you.
Thank you, Patel sir.